Hello, and thanks for joining the Reuters Global Energy Transition Summit. I'm here with Pedro Pizarro, who's President and Chief Executive Officer of Edison International, which is the parent company of one of the largest U.S. electric utilities, Southern California Edison. Pedro is also Vice Chair of the Edison Electric Institute, which is the main trade association for electric utilities. So he'll be a really good person to discuss with us kind of key issues in the U.S. energy transition. So thank you so much for joining us, Pedro.
Thanks for having me, Valerie.
Great. So let's start with a kind of broad question. How do you see the role of the electricity sector in helping the U.S. achieve its newly stated goal under the Paris Agreement, which is an overall greenhouse gas reduction of 50 to 52% below 2005 levels by 2030? How much does the electricity sector have to contribute towards that goal?
Well, two big contributions in different dimensions. One is the direct emissions from the second. Frankly, the more important one is the role of the power sector in helping to electrify a lot of the rest of the economy, to decarbonize those sectors. So taking those in turn, in terms of the sector's own emissions, if you look across the members of EEI, collectively, they have reduced carbon emissions 33% from 2005 levels already. And there's commitments in place to go to an 80% reduction from 2005 levels by 2050. So significant contribution there. In some ways, a more important role, though, is how you use that ever cleaner power to then decarbonize a lot of the rest of the economy. And at Edison, we had done some analysis a few years ago around California's own targets, right? California has set a 40% reduction from 90 levels by 2030 and then net zero by 2045. And we could get into more detail on this later if it's of interest, but the punchline is that getting there is affordable, it's feasible, it can happen, it will happen, but it will require significant increases in renewables and storage on the electric side. That's ways that we decarbonize the power sector directly in order to then use that clean energy to transform the economy. 3/4 of passenger vehicles and 70% of space and water heating going electric in the California example, along with other tools like storage or carbon capture and the like. So these dual roles are really important because net zero can't just be achieved with one single sector. It needs to be optimized economy-wide.
So you mentioned that a good number of members of EEI, Edison Electric Institute, have goals in place to achieve like an 80% reduction by 2050. The Biden administration, though, is kind of very focused on a net zero target by 2035, so much faster than 2050, through a clean electricity standard. So this kind of mandate, I guess it's sort of technology neutral, but would really favor heavy renewable deployment. I know EEI broadly supports a clean electricity standard. What is your view on the best policy kind of framework to really, sorry, Pedro, are you there? Okay, all right. So as you mentioned earlier, there are many members of the Edison Electric Institute that have plans or goals in place to achieve an 80% reduction by 2050, kind of towards the broader goal of the Paris Agreement. But the Biden administration has really set its sights on a clean electricity standard, which would kind of drive a net zero reduction or target by 2035, so much sooner. I'm curious of your view on the clean electricity standard. I know that EEI broadly supports it. Is this the best federal approach to support that transition? Is 2035 too soon? And I mean, how do I know some utilities say they can do it, but there's a question of getting that last, 10 to 15% reduction because technology might not be available yet. So what's your view on this kind of 2035 timeframe?
It's a really central question. And First, in terms of a clean energy standard, yes, we are broadly supported of one. Devil's always in the details, right? And so we would want to make sure that a clean energy standard framework, specifies the carbon reductions to be achieved, the time frame, applying broadly across all load serving entities, applying ultimately really broadly across the economy, or coupled with economy-wide reductions, right? Because as I said earlier, net zero for the economy can't be achieved just with the power sector. It needs all the economic sectors, all industries really working in concert. In terms, though, of the second part of the question around the administration's stated goal of net zero for the power sector alone by 2035. First of all, I have to say, I think directionally, we're all very supportive of going as far as we can, as fast as we can on decarbonization. So it's great that members already, have come up on their own with these commitments that get to 80% by 2050 for the sector. I think we're all looking at how much more can one do, right? And certainly in California, our state has set an even more aggressive target than the 2050 mark. It's set a 2045 mark. We support that. We were among the companies at Edison that supported the administration, in fact, encouraged the administration to sign the country up for an NDC with at least a 50% reduction by 2030, and resulted in the 50 to 52%, which I'm very supportive of. And we all have the humility to know that there's a lot of pieces we still need to figure out in getting to any target. In terms of the net zero by 2035, though, I do think that there are some significant technological feasibility questions yet to be answered. There will be, regardless of the time frame, there will be a significant need for investment in new technologies and in current technologies, developing new technologies, deploying current and new technologies both, right? And some of this might be more exotic, some of it is fairly mundane stuff, right? But hard to do. So the administration has, for example, focused on transmission being a key enabler, in which we agree. When we looked at our own Pathway 2045 analysis just for California that I mentioned earlier, we see a massive need for investment just in the power sector side across California by 2045. A need for something like $175 billion in investment for bulk power level renewables and storage, 80 gigawatts of renewables, 30 gigawatts of storage. That's on top of what we expect to be about 30 gigawatts of distributed renewables and 10 gigawatts of behind the meter storage. So massive lift, coupled with another 70 or $75 billion of wires investment in order to interconnect those resources. That's just California, right? So totally agree with the administration's focus on transmission as part of the equation. The reality is that today it takes a decade to build a transmission line, right? And most of that is not engineering or construction. It's the permitting process, right? And the planning processes to get there. So, one of the key messages for the administration is how do we shortcut those things so that we can make the deployment of that more feasible? But whether it's a hard net zero by 2035 or ends up being something else, we want to engage with the administration. We've appreciated the level of commitment to doing something about climate. But we keep coming back to the point that let's make sure we're thinking about how we optimize this pathway across all sectors of the economy. Because the reality, Valerie, is that the last molecule of CO2 that we remove from the power sector, that very last molecule is going to be really expensive. Think of it as a supply curve, right? Like any supply curve, it goes up and the last molecule would be really expensive. You can take those dollars, spend them instead to decarbonize other sectors, and you might end up with a solution that maybe tolerates a little more carbon, in 2030, 2035 in the power sector, removes more carbon, more greenhouse gases from other sectors at lower cost, which makes the transition more affordable, and therefore also more equitable for all the communities that need to be involved.
Wanted to ask you about the role of natural gas in the transition. And how do you expect, for example, California to meet its clean electricity goals, with only a little bit or not much natural gas? And are natural gas plants, both in California, but across the country, at risk of becoming stranded assets? So if another utility is kind of weighing right now whether to build a natural gas plant to kind of to meet their own, 80% reduction goal, I mean, is that a wise is that a wise move given all of these different goals and targets that we're seeing? And
so let me preface this by saying I'm going to put my Edison hat on. We are an electric-only utility, so we're not in the natural gas business. We also have very little generations. We're mostly a wires business, but we procure lots of generation for SCE's customers, therefore SCE is a large customer of natural gas for those contracts. Separately, we have Edison Energy, which is a non-utility affiliate. It's providing support for large commercial and industrial customers, like 15 of the Fortune 50, with their own procurement of natural gas, commodity power, renewables, etc. So different perspectives. But the point of that is that we are not a natural gas utility and don't have a vested interest. That said, we have an interest in the grid remaining reliable. And so even in California, in our analysis, which I keep coming back to, but hopefully it's instructive, what we saw was that for California to get to its net zero by 2045 in the most affordable, reliable, and frankly feasible way, it made sense to still have a bit of natural gas in the economy. It will be reduced significantly. So our analysis shows that natural gas commodity consumption across all sectors of the economy in California will be cut in half between now and 2045. And of that remaining half, 40% of that will be coming from renewable natural gas. So that's a very different economic equation, I think, for the pipeline operators, right? And the gas distribution systems, in that it's going to be a lot less commodity flowing through the pipes. They still have all those fixed costs. So that calls for a transition, right? And in fact, the California Public Utilities Commission has had a proceeding underway looking at the kind of questions you're asking about, how to make sure that the gas companies can continue to invest in a safe, reliable system in a way that minimizes the potential for future stranded costs. Because the reality is, gas use will continue to decline over time. Now, in the power sector, our analysis suggested that having something like 6% of wholesale power still coming from that gas as part of that 50% I mentioned, 6% of electrons being made by gas in 2045 yielded the lowest cost approach, right? And that means still having a few gas plants around for those peaking needs, right? Because that's a great resource in that sense. Coupling that with the other tools that we see as being important in the transition that I mentioned, increasing renewables and storage, the increase in carbon capture, right, to offset those remaining emissions. That leads to a lower cost solution overall. But importantly, it's not a zero gas solution in our view. Again, if you buy into the premise that we should try and make the transition as affordable as possible.
The transportation sector is the largest source of greenhouse gas emissions in the US, obviously more than the electricity sector. What do you see as needed to kind of get more drivers choosing electric vehicles? What would give them confidence to make that kind of consumer choice? And then, what are the opportunities with respect to medium and heavy duty vehicles?
Yeah, so we need vehicles. The auto industry is stepping up, and we're seeing the number of vehicle options out there available rising dramatically. I just saw the latest announcement from GM this morning, increasing its targets for capital spend by another 75%, I think 35 billion over the next several years. You've seen the same from Ford. So great to see that piece. Secondly, we need the charging infrastructure to be able to keep those vehicles fueled. And really proud that Southern California Edison at this point has, I think it's the nation's largest utility-based charging program to basically make ready infrastructure in order for customers to be able to connect chargers. We've now had around $800 million approved by the Public Utilities Commission for charging programs for both passenger vehicles and, to your point, for medium and heavy duty vehicles. It also will require support, particularly in the early days of the transition. If you look at a lower priced passenger vehicle today, electric passenger vehicle today, from a total cost of ownership perspective, we believe that that's already achieving parity, probably most parts of the country, relative to gasoline-fueled vehicles. However, the upfront cost is still more expensive, right? That over time will hopefully converge as battery cell costs continue to decline. And then you've seen the research out there that says that lithium-ion cell costs have come down by something like 90% over the last decade. So, hopefully that will continue. And, I think this is one of those areas where the federal government has a major role to play in continuing federal investment in new technologies. I'm on the board at Argonne National Lab, and Argonne has been the hub for DOE's research on new chemistries for battery technology, Joint Center for Energy Storage Research there. So exciting stuff going on that will help bring that down. But in the meantime, the average consumer is looking at, call it 10 grand more to spend on that electric vehicle. And, consumers often make a decision based on that upfront cost. So two ways to help solve that. One is more and more education, which we're engaged in with our peers at EEI, and I'm fortunate to co-chair EEI's CEO task force on transportation electrification. One of the areas we're engaged in is that consumer education, right? But the other is the role for government incentives. So whether it be tax incentives, continuation of the $7,500 incentive that we have in place today at the federal level, extending that so that it covers more vehicles for the manufacturers that have already met the 200,000 vehicle cap. Those incentives are important, and they pay off in the end because they help the economy transition to a more affordable, electrified pathway. On the medium and heavy duty side, exciting there too. We recognize that for some of the tougher, longer haul applications, direct electricity may not be the best tool in the end. And so in our California analysis, we concluded that we'd see something like 3/4 of all passenger vehicles on the road in 2045 be electric, about 2/3 of medium duty vehicles, and about 1/3 of heavy duty vehicles be electric. It's important then to be looking at alternate fuels, clean fuels beyond electricity that can then help power the rest of that. And so I just finished a year as chair of the Electric Power Research Institute Board, where we're members of EPRI. EPRI has some really important work underway right now with the Gas Technology Institute called their Low Carbon Resources Initiative. And that's looking at what are those alternative fuels like hydrogen, right? It's probably still made with electricity, hopefully made with renewables so that it's then a low carbon fuel, right, as opposed to using natural gas and methanation to get there. But we do see that we'll need more tools in the quiver here, more tools in the toolbox in order to then deal with the hard to electrify applications. But there's definitely significant potential in medium and even some heavy duty for electric transportation. You're seeing that interest from the fleet operators. You're seeing what Amazon is doing in terms of their contract with Rivian, right, for massive deployment of electric vans. You've seen the announcements by a number of automakers in the medium and heavy duty space. So a lot of potential there.
Right now, the administration or in Congress, they're grappling over what will be in an infrastructure package. Obviously, this administration would like to see, the White House would like to see a real focus on kind of measures that would really accelerate the clean energy transition, the electrification of vehicles, buildings, et cetera. Obviously, a point of contention with within Congress. But how, failing a massive infrastructure package that can get passed, how can the U.S. get the grid ready? for this rapid transition, which is happening one way or the other. It's happening.
Yeah, I agree, Valerie. This is definitely happening. Frankly, it was starting to happen even under the prior administration. So, and it's the right thing to do for the globe and for climate. The grid will be ready, right? But it will require a lot of work. And again, as we look at the California example, just last December, our utility released a white paper called Reimagining the Grid. It was a follow-on to our Pathway 2045 white paper that I've been mentioning. And because we wanted to look at what kinds of new steps will we need to take to make sure that our grid is ready. And we see that the pathway to decarbonization through clean electrification will put a lot more stress on the grid for sure, right? So, and that analysis that I keep, going back to, we saw that total electricity demand across the state will increase by 60%, 60% between now and 2045. Now, mind you, that's huge because over the last decade, consumption in the state has been flat to slightly declining. We've had, the impact of increased penetration of distributed energy resources like rooftop solar, which is, a great addition. We've had continued focus on energy efficiency. The state has been a leader in that. As we look at the path from now through 2030, we see those two still continuing and basically offsetting the load increases we expect from electrification over the next decade. But as you get past 2030 and go to 2045, that curve really bends up, right? Because of the massive scale of electrification needed to get to net zero. And that's where you then pick up the bulk of that 60% increase. It's not just about demand, by the way, it's also about peak load, which is probably the more relevant number to think of if we're thinking about stress on the grid. And so we see peak load going up by 40% between now and 2045. So what does that mean? It means that we need a more robust grid, continuing to modernize the grid, bigger wires in places. We've been for a number of years now going through and replacing some of our older, weaker circuits. In technical terms, these are circuits that operate at 4,000 volts. 4,000 volt circuit serving however many houses is just not good enough. You're going to have a bunch of electric vehicles and electric water heaters and solar panels that are reversing the flow of electricity during the sunny times of the day. So we're upgrading those to 12 or 16,000 volt circuits, right? We need more deployment of storage to help balance out, the issues on the grid. And so storage is not just about balancing out renewables on the bulk supply side. Storage is also about bringing in more flexibility down to the grid level. We need improved power electronics and grid control systems. We will have a much more complex network because instead of having for our network, what used to be maybe 100 nodes of supply coming in, thousands and thousands of nodes with more and more distributed, solar panels and storage and, potentially bidirectional charging from electric vehicles. Mm-hmm. And oh, by the way, that creates a more interesting, more flexible, but more complex surface that will need more protection from a cybersecurity perspective, right? Right. So we need to continue to increase the level of cybersecurity protection that we have on the system. This is doable, Valerie. It will require significant investment. And that's where I think whether it's through an infrastructure bill, or whether it's through a continued work by Public Utilities Commission, we have to get the transition right. And, one last point, we need to make sure that that investment isn't just happening in the neighborhoods that today can afford an expensive electric vehicle on the upper end. We need to make sure it's happening in the disadvantaged communities where we need to help people get into a second or third hand electric vehicle and make sure they have infrastructure there to handle that as well.
Finally, I wanted to kind of ask you something just because it's very timely. California is leaning very heavily on utilities to harden their systems and remove vegetation to combat wildfires. The maps look very dire. The prediction, the wildfire forecasts are quite scary. Can you talk a bit about how efforts over the last couple of years have maybe reduced the need for de-energization events, Or do you expect that Southern California Edison will kind of have to do more of these events because of elevated risk? And, just talk to us about, preparation for this very, very powerful wildfire season.
Yeah, absolutely. And look, let me start by saying California's always had wildfires. But what we saw starting around 4 years ago in 2017 was a massive step up in terms of the potential scale. I don't think anyone, the state, utilities, firefighters, I don't think anybody had envisioned catastrophe at that scale. So we saw that in 2017, we saw it in 2018. We already had a number of activities underway even prior to that to help mitigate wildfire risk, but we went back to the drawing board, Valerie, and significantly redesigned how we do this based now on a much larger potential risk that all of us perceived. A lot has happened in the last 4 years, and I think there's still significant risk for the state. There will always be, but that risk envelope has narrowed down a lot. And there's from a physical perspective, there's been a number of actions, but I'll point out just a couple or three. First, you mentioned the actions that the utilities are taking on, and so that's certainly helping to reduce the risk that the ignition source is our wires. We filed wildfire mitigation plans and are implementing those. It's a massive undertaking, billions of dollars of new capital investment in order to harden the grid. For Southern California Edison, it means things like replacing standard bare wires, right? Wires are insulated by air and space typically. Well, now they're insulated with actual insulation, because in the 27% of our 50,000 square miles that are high fire risk areas, it makes sense to now cover those conductors with insulation in case that a palm frond flies during high winds and ends up making contact across two wires and creating a spark. Covered conductor is a significant risk reductor. We've installed other technology and are installing other technology like fuses and circuitry that helps to take out the energy that is released when there is a fault condition and do it much more quickly. That then helps reduce the chance of an ignition. We have been stepping up significantly our vegetation management, more frequent inspections in high fire areas, frankly, more conservative, trims, much more situational awareness and monitoring, vast network of high definition cameras to spot fires early. And, we turn over control of those to fire agencies so they can, see where the fire is going. Weather stations and supercomputer models to help do better forecasting, and also help us to identify when we might have the kinds of conditions that merit the tool of last resort, a public safety power shutoff. We've been doing a lot to reduce the need for those PSPS events, both through the hardening, but also for a number of years, even prior to 2017, we have been doing work to more finely divide up our grid. We call it sectionalization. So, we have 4,500 distribution circuits, but on average, in high fire areas, we can divide those into 4 segments. And we are continuing to increase the number of segments into which we can divide, such that if there's a high risk area over here, we think we absolutely need to turn the power off because conditions are so dire, we can turn the power off there, but not over here, right? Because we've broken up that circuit segment. So a lot that's been going on the utility side, but that's not all. We also then have to give a lot of credit to the state, particularly in the firefighting area. And the step up in firefighting has been dramatic. If you look at the latest governor's budget submission, it added something like another $2 billion in terms of firefighting. So we've seen a significant step up over the last number of years in number of firefighters, funding that they have, equipment, modeling tools, et cetera. Those are all about physical risks. There's more the state needs to do, continued forest management, stronger building codes for homes in high fire areas. There's also then the financial risks, particularly to utilities, because California has had this inverse condemnation approach. Won't go into all the details there, but I'll sum it up by saying that a couple of years ago, the legislature passed a bill that helped to redefine the framework for how utility actions are measured, and provided some liability limits that then help to constrain and frankly make more appropriate the financial risk that utilities face, given that we have an obligation to serve everyone everywhere. And so we can't simply choose to disconnect our wires in high fire risk areas.
Okay, great. I guess we'll kind of bring it back to the transition, and I'll just ask you a quick question to wrap up. What do you see as the biggest, trend to watch, or what is something that you think might surprise people as as companies kind of grapple with this rapid transition to clean energy?
So I'm a scientist by background and training. I'm a big believer in the power of technology. And I do believe that we will see the technologies continue to spring from the labs into commercialization that are going to make the transition absolutely possible and affordable and reliable. I also think we're going to be surprised by the pace of adoption. And, if you go back to the forecast for things like cell phone deployment, right? Humans, we tend to extrapolate in linear fashion, and people have a really hard time forecasting the big exponential rises. I think electric vehicle adoption is going to be one of those, and I give credit to the automakers who are making big investments now to have the supply ready as consumer adoption increases. And frankly, I give credit to my utility peers because we're all then trying to invest ahead of that, making sure that our grids are ready and ready for providing the charging support that's needed for that. That's just one example of technology, but there's a lot more investment that's needed in R&D across better sources of clean electricity, better forms of storage, better forms of carbon capture, better appliances that can use that clean electricity across all sectors of the economy. But I'm optimistic about that, and I do think it's going to require some tough policy choices. It's going to put some stress on the economy in the early days. But I'll leave you with this final punchline from the analysis that we did for the California example. I mentioned that $250 billion of investment needed to get renewables, storage, and the grid ready. There's additional investment needed then for consumers to buy their electric vehicles and their electric heat pumps and whatnot. But here was the punchline that frankly surprised us. If you make all that investment and you get out to 2045 for California, and I think we'll see similar trends at a national level, that transition actually opens up a whole new world of affordability for customers. And what we found was that the average customer in 2045 in California will actually be spending one third less on energy out of their wallet than they do today. I mean, across all energy sources. Wow. They'll be spending more in electricity because they'll be using more electricity. They'll be spending a lot less on gasoline. They might be spending zero on that. They'll be spending less on natural gas. But when you add it all up, it'll be a third less for the average customer because the electric technologies are so much more efficient from a physics perspective. Less energy needed to get work out. And so that promise of affordability is something we need to keep in mind as we think about the investments needed, the incentives needed to help particularly our disadvantaged communities and communities of color participate in the transition. But there's a great pot at the end of the rainbow. And it means an economy that's going to be a lot cleaner in terms of greenhouse gases. It'll be cleaner also in terms of just the air we breathe, because we'll be removing diesel trucks from the roads. We'll be removing other sources like that, but importantly, be more affordable as well.
Okay, great. That's a very good place to end this. Thank you so much, and look forward to your other sessions in this conference. Thank you.
Thank you so much, Valerie.
Hello, and thanks for joining.